Like we said in the introduction, I'm a Scientix ambassador here in France. I'm also a member of Team France for the Science on Stage Festival. I don't know if anyone in this Zoom was there last weekend in Prague, or if you've heard of it, but Science on Stage is another great network across Europe for sharing experiments specifically and experiment-based projects. Like most of you, I'm a teacher as well. So I'm used to being interrupted. So anytime you have a question, don't be shy. Feel free to jump on your microphone and stop me to ask a question. I get that all day long with my own students. And I often say, only half jokingly, interruptions are great because it shows that someone has something more important to say than what I had to say. But really, don't feel bad if you want to interrupt me to ask me anything or make me repeat things, go back and forth. And what I'm going to do for most of this talk is introduce myself and some of my projects. But as I introduce them, I'm going to stop every once in a while to share some experiments, because that's my favorite part of teaching. And I always like to bring in experiments as much as I can. So when explaining who I am and how I teach, necessarily I need to bring in some simple experiments, hopefully a couple of which you'll end up repeating even as soon as tomorrow with some of your own students. Everything okay so far?
Yeah, go.
Okay, so I'm going to start with the idea, I call it the disease model for the spread of good ideas. And during a pandemic, it's a good time to talk about how diseases spread from one person to another. And I follow this, the principle that science is the same everywhere in the world, but how we teach it is really different from one place to another. And part of that is how new ideas for how to teach it, or specifically how new experiments pop up from one place to another. So if someone comes up with a great idea for an experiment, they'll be like the patient zero. And their idea probably comes from something that existed, just mutated or modified in a different way. So we could try and figure out where it mutated from, but sometimes by the time it pops up, it's original enough we can't trace anything beyond that. And from the patient zero, if a teacher has an experiment that works really well in class, they'll probably share with other teachers around them, like the teacher teaching the lab next door, maybe their friend in another town, maybe through a teacher network like this. And if it works really well, it'll spread from person to person, but we'll end up with different pockets where different experiments are more common than others. And I noticed this in my own teaching. So I started teaching in Canada where I grew up. But when I was a young teacher, I moved to the UK. I taught in England, then in Scotland. And I noticed some of the experiments were the same there. Some were fairly different. Not long after that, I got to France, which had yet another set of experiments. And again, a lot of them were in common, but some were a little bit different than others. There's one specific one that I'm going to mention a little bit later on, where I actually found patient zero. But first, to give a demonstration of this, I'm going to show one of my top, like all-time favorite experiments. And I learned this from a student of mine in Paris back in 2016. So for this one, all you need is 2 plastic straws, a water bottle, and technically all you need really is the cap of the water bottle, and other materials to rub against it to test. And it's the simplest and most effective way I've found to teach about static electricity. So what I'm going to start with is some toilet paper. I just took it from like a roll of toilet paper. And I'm going to rub the straws against the toilet paper. Now, I think everyone on this call is a teacher, and some of you, hopefully at least, if not all of you, are science teachers. So I want everyone to make a prediction. Now that I've rubbed the straws against the toilet paper and I set this straw on the bottle, I'm going to bring the toilet paper near the straw. And I want everyone to predict, and I'm going to count to 3, and I want you to write in the chat if you think it'll attract and pull the straw towards, write an A. If you think it'll repel and push the straw away, write an R. And if you think it'll do nothing at all, write N. Does that make sense? A for attract, R for repel, N for nothing. On the count of 3, write it in the chat. 3, 2, 1. And I'm going to look at the chat, and I'm not going to show you the results until I have at least like 1 or 2 predictions. Very good. We have 1 prediction to repel. At least 2 or 3 more people need to take a guess before I continue. I can wait. I have patience. Don't worry if you get it wrong. Just write anything in the chat to show that you're listening and you're capable of replying. Okay, we have another R. That's 2 people interacting with me. Okay, some disagreement. Repel or attract. Another attract. Okay, that's tied. And I see you guys are a little bit shy to warm up, so I won't wait for everyone to reply, but let's see what happens. And we very clearly see attraction going on here. So this is, of course, a demonstration of electrostatic attraction. When the straw was rubbed against the paper, electrons were transferred. From this experiment, we don't know whether they were transferred from the straw to the paper or the paper to the straw, but we know they have opposite charges, and this demonstrates opposites attracting. Okay, now that you've warmed up with that same question, A for attract, R for repel, N for nothing, when I bring the second straw near the first, is it going to repel, attract, or nothing? So the paper attracted, the other straw. Okay, Tina thinks it'll repel. Let's give it another 10 seconds for 1 or 2 more predictions. Okay, someone thinks it'll do nothing. And depending on how I ask the question, I can actually get both right. So the unrubbed end is doing nothing at all, but the rubbed end is repelling, and that's because they've picked up the same charge, and like charges repel. Now the tricky question, if I take one of my hands and my hands aren't charged, if I bring it near the charged end of the straw, will it attract, repel, or nothing? And while waiting for the reply, just to apologize if I'm coughing a little bit. I, like the rest of Team France at the Science on Stage Festival, I caught COVID last week, and so I'm still getting over it. I should be good to go back to school from Wednesday, but if I'm coughing a bit or if I don't sound that well, it's a good thing we have not only screen between us, but probably 1,000 or more kilometers, so you have no risk of catching it from me on this Zoom session. But sorry for the occasional coughing. Okay, so it seems that it's a mix of predictions. Let's try this. And things do discharge over time. So if I left it too long talking, it'll do nothing. But there's still some charge on the straw, and it's attracted to my finger. So this is showing induction. And induction is always an attractive force. And induction, of course, when the straw is charged, it's going to attract similar charges in my hand that are going to slightly move towards it and attract unlike charges slightly closer to it, repel unlike charges slightly away. So overall, it'll be an attractive force. So that's the first experiment I wanted to show you as a demonstration. Oh, and as I continue, or before I continue, please stop me if there's any questions on this. And can I ask, well, really anyone can answer this, but maybe Aynur or Beril, am I getting your names right? Tell me if I say them wrong.
Yes, right.
Yeah. Okay. And are the teachers, are most of the teachers in this group, are they science teachers, or are the English teachers looking to teach STEM in English, or are the other teachers? Like to know how much detail to explain some of the experiments in.
Both science and English teachers were together. But
Okay.
we haven't know much things about STEM. So it's, for me especially, new things.
Okay, so it's a very mixed group. And is it both primary and secondary?
Secondary.
Okay.
Secondary, we all secondary, but we all an English teacher, and but we have some other subject. We have student here too.
Oh, excellent.
Yeah.
I think this experiment was very interesting for me because I can't understand how it will be round or it will be stopped. And I think it will be interesting. And we can use it for warm up in our school in English lesson. How do you think? Only for game, we can say some words and do this experiment in English lesson.
Exactly. And I know from experience doing this in a couple of different places. There's one time I was doing this experiment in Spain, and for some reason I'd learned the wrong word for straw. And so for the whole lesson, I'd be stopping mid-lesson and I'd get the students to repeat the name for straw for me. And like same with a couple of other objects I had. So it can be a fun interactive way to get students to remind vocabulary, as long as you tie the vocabulary, the experiments into the lesson.
Yes, especially toilet paper appeals my student too much, I think.
Well, and most places you can get toilet paper fairly cheap. Like if you send a student to the school toilets, so some places they supply toilet paper, some they don't. But generally it's not that hard a material to get a hold of.
Yes.
And so this is one example of an experiment that, from when I learned it in winter 2016, and I assigned my students, we were studying static electricity, and I gave them a couple of weeks. Near the beginning of the topic, I showed them some interesting demos, and I said, your homework for the next month is to come up with the most interesting new demo that I haven't seen before in static electricity. And at the end of the topic, you're all going to wow me, and I want new ideas that I can use in my own teaching. And of course, most of the ideas they came up with, they showed me things I'd seen before, sometimes in slightly different ways. So sometimes, not all students do their homework, and not all students do it well. But when one student named Alex came up with this one, I'd never seen it done this way before. And it's very simple, but it worked so well. The very next day I did it in all of my classes. I had 2 classes at the same grade level learning it. And then a month later, I was in Cambodia, the first place I ever went to do volunteer teaching, like during school holiday. I was teaching students and running workshops for teachers, and they claimed they could never teach static electricity there. And I said, oh, I think I have a trick. I learned it from my student last month. So it's great how we can share ideas for experiments from one place to another. And so I wanted to start with that one. A couple with the same idea that if we go from one place to another sharing experiments, I can be a vector for the spread of good ideas. After teaching in France for 10 years, I wanted to go back to my home country of Canada, see what kind of experiments I could find across the whole country, then share them back in France. It worked really well. So the next year I did the same thing in Europe, which is about the same size as Canada, surprisingly. And so still biking 10,000 kilometers or so, instead of just being in 2 countries, Canada and the United States, I went through 20 different countries, starting in Portugal, finishing in Turkey, met hundreds of educators, sharing a bunch of ideas, filmed a bunch of experiments for my YouTube channel, and kept sharing ideas forward like that. The next year, I thought I'd learned so many things. Oh, but before getting to what I did the next year, the idea of finding a patient zero, and I said earlier, I'd give an example of how you can find a patient zero for certain experiments. So patient zero, like for a disease, is the first patient that you know of to have that new disease or that first patient in an outbreak to have brought it to an area. And there's an experiment that I started noticing around 2014, 2015 in France. And it's a very simple one. I'm not going to demonstrate it today because I don't have a pH indicator at home and I'm confined because I have COVID right now. Otherwise, I'd probably show it. But you can see from the picture, I've got a purple liquid there. That's just a cabbage pH indicator, and you can use a lab pH indicator. And if you get a bunch of test tubes or glasses, either one will work, most of which have just plain water, and some have some have either an acid and alkali, like hydrochloric acid, or like sodium hydroxide. In this case, we used vinegar. So colorless, you can't tell it's there. And then you encourage the students to go out and mingle with each other and to exchange fluids, which could either be pouring a bit of liquid from one to another or with a pipette going from one to another. And so after they've mixed for a while, you'll have some students who have acid in their water and some who don't. And until you test it with a pH indicator, you won't know who's been infected by the acid. So that's a way of modeling how a non-symptomatic disease could spread through a population. And I noticed that this experiment was particularly popular with Canadian teachers I was meeting in Europe, which seemed odd. Like, I'd grown up in Canada. I didn't know that experiment when I was there, but teachers who had recently moved from Canada, there were 2 or 3 who had suggested and had done the same experiment in my school in Paris. And I thought that's weird. This must be a typically Canadian experiment. And so when I came up with the disease model for the spread of ideas, I was explaining this to some people while biking across Canada. And when I met the national coordinator of a science outreach group called Let's Talk Science, she said, "Oh, I know that experiment. It's a friend of mine who came up with that one. She was in Let's Talk Science at the University of British Columbia at the time." And so from there, the idea had spread out, and it was common in Western Canada once I'd already moved to France. And now people from Western Canada around the world are spreading the idea of that experiment.
Great.
And so from those first couple of years when I was testing out this idea, I started a YouTube channel. I filmed videos in 20 or 30 different countries. But then the question was, rather than just gathering more ideas, how can I share those ideas forward? And so the next year, the focus was what kind of projects I could do to get things beyond my own school and beyond just the next people I was meeting. By the way, is the sided screen blocked for you guys? Sometimes it like, can you not see the word yes now, and now you can see yes?
Yes.
Okay, so I just need to configure where things are showing in Zoom so I'm not blocking too much of the screen. So during that year, I decided to volunteer part-time at UNESCO headquarters. So not everyone outside of Paris really knows or cares, but UNESCO, which is the educational, cultural, and scientific branch of the United Nations, UNESCO headquarters is right in Paris. And it's only about a 5 or 10 minute bike ride from my school. So I managed to balance my teaching schedule, which I'm about 3/4 of a full teaching load. In 2017, I decided to take on less classes to have more time to dedicate to sharing ideas more widely than my own school. So with that amount of time, that was about a day a week. Then I volunteered about a day and a half a week at UNESCO headquarters, going back and forth between UNESCO and my classes. And at that same time, I also started volunteer teaching in Ghana, West Africa, with a friend of mine who I met at CERN, who's a teacher at a college of education. And I started a science outreach group at my own school. And you can see 2 of my students that year, Anna and Alice. Can't believe I forgot Alice's name for a second. And they're teaching a a lesson actually to student teachers in Ghana on a homemade thermometer using a beer bottle, a bung, and a couple of simple materials.
Are they university students?
Exactly. Well, not anymore. In 2019, they were my students, and they graduated last year.
Okay.
So they were my students. Now they're both in the United States. Yeah, they're both in the United States. One East Coast, one West Coast. And I'm hoping to get them on a couple of Zoom calls, because now, like I'll mention in a couple more slides, I'm running Yes International meetings where we're sharing experiments between students in a lot of different countries. And so some of the earlier members of Yes, I've asked them to come back on, and that they've tentatively agreed, but they've got a really busy schedule, so we haven't figured out when yet.
Yes.
Are there any other questions before I move on?
Have you ever been in Turkey before?
Have I been, pardon?
Have you ever been in Turkey before?
Yes, I've been in Turkey. Can I show you a visual of, I guess it doesn't show very well because there's other stuff covering it, but here you see where I traced out the route that I biked in 2018, and I finished in Istanbul. And I visited a friend who's a teacher. I forget the name of his school, but he's changed schools. But I was in 2 or 3 different schools to talk about different experiments I'd shared. And I was actually supposed to be in Adana in southeastern Turkey.
Yes, Adana.
Adana.
I had tentative plans to go back there later this week. But a number of other things, including catching COVID, caught up. So I'm not going there this week anymore, but I definitely intend on coming back to Turkey sometime.
Get well soon, by the way.
Oh, thank you. And so, and one cool thing I like about Turkey too, and you probably know a lot more about this than I do. Like maybe I have the wrong idea with what it's like, but how it was introduced to me was that most towns have a teacher's hotel or hostel, and there are teacher restaurants where you get special rates. And sometimes my friend making the reservations for me and me showing proof that I'm a teacher in France, I could get the teacher's rate there, but sometimes because I'm not a teacher in Turkey, it didn't apply to me. But it just seemed like a really nice thing to encourage teachers. Like I think it's mainly for going to conferences or collaborating with other teachers, or just to have some kind of benefit. But it seemed like a really nice benefit that teachers seem to have in Turkey.
Yes, I think so.
And so continue on. Well, actually, are there more questions before I continue on?
No, I think we can go.
Oh, okay. So in 2020, like all of you will probably remember, it became significantly difficult to travel physically different places for a while with the pandemic. And during the first couple of weeks of the pandemic, I went through a whole bunch of ideas for things that I could try and do to help the situation. Like I contacted any doctors I knew and asked if they needed volunteers to do stuff at the hospital. And they said, no, you have no idea what you're doing, that we're not interested. A similar thing, the Pasteur Institute in Paris, they're a big microbiology research center. They were one of the first places to sequence the genome of the coronavirus. And I asked them, with all the new work you're doing, the new discoveries, do you want any teachers to come up with how teachers can teach about what you're doing right now? And the answer was also, no, we're busy. We're not interested in you. So eventually my solution was to use what I knew about hands-on experiments and ideas for low-cost hands-on experiments to get students around the world using their kitchen like a science lab. And so I came up with, at the time, I was having almost daily sessions where there'd be students joining from anywhere I could invite people. And that's actually one of the things that got me interested in Turkey as well. I had 2 or 3 friends in Turkey, and they spread the word. And so regularly amongst the 20 or 30 other kids from about 10 or 15 countries. There were usually 4 or 5 students from Turkey who'd come along to all these sessions as well. And I think, yeah, I think I plan to share one of my favorite experiments from that. And, and it involves a challenge for everyone as well. So I'm just going to lower my camera a little bit lower so you can see this water glass. Oh, and I'll stop sharing my screen so that you can see the experiment more full screen.
Sorry, can I ask something?
Yeah, of course.
About the previous scene, I saw that the CERN logo, CERN laboratory. Am I right?
Exactly, yes.
What is the relation with it, or with you, with CERN laboratory?
Oh, okay. That's an excellent question. So, and I'll answer it a bit more afterwards, but like the first part of it is that in 2018, I participated in CERN's international teachers programs. And so I spent 2 weeks at CERN there were 47 of us from 38 different countries. So it was quite an international group. There was trying to think how to describe the group. I was there were no teachers from France. At that time, even though I'd been living in France for a decade, I wasn't a French citizen and my application was considered as a Canadian application. There was another teacher in France who's English, and so it was considered an English representative. But there were 2 or 3 from Spain, 3 or 4 from Germany, 2 from Turkey, a whole bunch from other places. And I think I'd mentioned that earlier because Christopher Akpolu, who's a friend of mine in Ghana, who I go every year to teach with, I met him at CERN as well. And so like the part of the story so far where CERN had a big role was that introduction, and also how I met a lot of the different teachers I visited. So I was at CERN in August 2018, and I'd taken a break from my bike trip. I guess I'd gotten as far as Riga in Latvia. And so continuing from there, then once I got to Lithuania, I knew a teacher I'd met from CERN, and I met her there, visited her school. In Poland, I met a teacher in Torun, where Copernicus is from, and he had worked at the observatory there, so it gave me like a VIP tour of the observatory. In Serbia, met another teacher who I'd met at CERN, and so it was a very good contact point to have contacts throughout Europe, in addition to everything that we learned about particle physics.
Yeah, it was a great thing to be in there, because I think that place is the top place for science, I think.
Definitely. Like, it's the biggest science lab in the world, and they're doing great things both with their teacher programs and with their outreach. But an additional thing, and this is something that I've been asking them or requesting to them a couple of times over the years, in addition to everything that they're offering at CERN, the network of teachers that they bring together, by nature of being a highly competitive program, like I needed to apply a couple of years in a row before I was accepted. And I like to think I was a pretty strong candidate, but like, no matter how strong a candidate you are, if there's several hundred teachers who are applying for less than 50 spots, yes, then they're going to be very selective. And almost all of us who I met up with afterwards were very interesting teachers. I would say some of the best teachers in the world, and they were excellent contact points for their country. So not only were they interesting people to stay in touch with and often doing interesting things, but if I say I'm going to your country, are there people I can meet? They'll have a list of 10 or 20 other people who would be eager to meet me or to collaborate on different projects.
Right, a big chance.
Yeah, exactly. So like, aside from having great programs, the trickle-down effect is the people you meet on programs like that are also very excellent.
It is a free program. Was it a free program?
Yes. Not only is it free, but they also pay stipends. I don't remember the exact amount, but because to attend the program is free, but then you need to pay your own travel and accommodation. But
Okay.
they have like a stipend or a grant that they give each teacher to go there. And it's something between 1,000 and 2,000 euros that they give. So it's quite a large sum of money. Geneva is quite expensive. So for accommodation while you're there and things like that, you end up depending on how careful you are with money, you could go way over what they give you. But like I was often trying to save money, like along with the teachers from Africa and from Asia. And so a lot of us, we probably didn't fully spend all the grant money that they gave us.
Oh, okay.
Like it is quite a generous grant. They also have national teacher programs, although there's big priority given to member states. I don't remember, is Turkey an associate member, or is it not associated with CERN? I know they talk about Turkey for teacher programs. It comes up as one of the countries where there's the most interest and where there's the most interest for online events. So they even, with some of their online trainings, they decided to add additional ones in Turkish because there was such a great interest from Turkey. It didn't make sense to have some of the English language ones that were mainly Turkish speakers. So they did add extra programs for that. I don't know offhand any more information about that, but like if you want, after this session, I can give you emails of people in charge of that, or like share links of where you can find more information on.
Okay, thank you so much.
Oh, my pleasure. So getting back to the experiment I was about to share, and I'll make sure that I spotlight my camera, so I should appear big for everyone. Correct me if I'm wrong on that. And so I have a water glass, and I have a bottle cap from a bottle of water, similar as the bottle of water for the straw experiment. And I'm just going to fill the glass half full. And this is something I encourage you to do at home if you have a glass and a water bottle handy. If not, then do it like tomorrow or the next day or sometime in the near future. Oh yeah, and I'm just going to set the camera up slightly higher so we get kind of a top-down view. And you'll notice when I place the cap in the middle of the glass, when I let it go, it always finishes by sticking to the side of the glass. If I get it like exactly in the middle, it might take slightly longer and I might not know which side it's going to, but it'll always go to one side or another. Not only that, once it gets close to the side, if you look closely, it seems to like speed up and accelerate the last little bit. And you can even hear it, like if I bring the microphone close, you can hear a small clink as it speeds up and it hits the glass. So just from this observation, my question to everyone is, what can I do so that the bottle cap will float in the middle of the glass? The other part of the question is, why does it always go to the side?
It is very light, that's why it is moving on the water. Maybe you can drop there some water, maybe it will be.
So like if I fill the cap with water?
No, not full. A little.
Oh, okay. Oh, like a little bit of water in the cap so it'll move slowly?
Yeah, I think maybe.
So that's a good try, and it'll move slower. It's not moving as fast, yeah. But it always ends up against the side still. So we can see it's attracted to the side. Mm-hmm. And to explore why it's attracted to the side, I'm going to bring a Frisbee to act as a bigger dish. And now I'm going to float a couple of caps in it. And I'm just going to add a little bit more water. And notice if we set them floating freely, they'll always eventually end up either connected to each other or connected to the side. And I'm just going to add a couple of more caps so we can see how they behave together. Notice I haven't touched it. Now they've ended up stuck together. And I'm going to add 2 or 3 more caps in here. And as they get close, you see they stick together. So there's some force which is sticking.
Is it because it's smooth and plus light, maybe?
Smooth and which?
That's why sliding.
Okay, so
smooth.
So it can slide smoothly through the water, but just being smooth doesn't explain why they stick to each other.
Okay.
And to further confuse things, paper clips. I've just pulled my headphones out for a second, so let me know if you can still hear me. Can you still hear me okay?
Yes,
Yeah.
we can hear you.
Yeah.
So with these paper clips, I'm going to very gently place the paper clips in the water. And notice the paper clips, if I'm not careful, they'll sink. But if I'm really careful setting them down gently, then they should be able to float. And they're floating on the surface. Oh, this one's a Spanish paper clip. There's a bit of a story there. So I'm not going to use this one. I don't know if you can see it well, but Spanish paper clips have a curve that goes up to hold paper on. And they don't work for this experiment. They don't work very well at all. So when I was in Spain, I found that out and I took some back to tell the story of that, but they've gotten mixed in with the other paper clips. So carefully setting it down. And actually, I'm going to grab a fork so it'll go a little bit quicker. And as we compare how they float, so they're both floating, the paper clips and the bottle caps.
You can take a color for pink or white one. I think they are very light.
The colorful one?
Yes.
Well, we'll see. It might be a little bit too big. Yeah. Okay, so when I have it floating, notice it doesn't attract to the caps. And if we try and force it near, we see it actually gets repelled. So we see the caps are repelled by the paper clips. The paper clips are attracted together and the caps are attracted together. And the reasoning for this has to do with adhesion. So adhesion is the tendency of water to stick to surfaces. If I bring this glass back, I've emptied it out, but you can see there's drops of water on it. It's not perfectly dry, and that's because water tends to stick to surfaces. So if we fill the cup with water again, water tends to stick to the side. So on the side, the water will climb up slightly, and it'll be slightly higher up. We'll find the same thing on the side of the bottle cap. And so when the bottle cap floats up, and we can see if I push it down, it goes up higher again. It always looks for the highest point, and the highest point is right at the edge of the glass. And we can even see that because of adhesion, the water's climbed up and we have it wet all the way to the top. The same thing is happening between each of the caps. And so with these extremely simple materials, it's possible to do experiments demonstrating adhesion, cohesion, on the effects of surface tension. So it's experiments like that and a number of other similar ones that were kind of the backbone of my virtual science camps through 2020. And that was one of the things that got me and a number of students through the first lockdowns when we couldn't do experiments together in person. And I really loved it because, as I mentioned before, I'd sent the invitation out to all of my friends, especially friends I'd met at CERN, but really from all around the world. Anyone who wanted to come along was welcome. So I had students usually from 10 or 15 countries who would show up to any given session, and often still only being like a comfortable class size group, like 30 or 40 students, but very international. And so once the lockdowns eased up, like even now, not all the rules have fully gone away, but things have gotten a lot easier. And school got back to being in presence. I missed having these regular classes with students all around the world. So I decided to try and come up with ways where it'd still be interesting to keep doing experiments with me. And I came up with the idea of particle physics for kids. So this is where, and I should be sharing my screen again. Please let me know if you can see. This is probably the wrong
Not
screen.
now, we can't see.
Okay. I lost my slides. Just a second. I should be able to find them again.
Mm-hmm.
Okay. There, now can you see my slides?
Mm-hmm.
Okay, perfect. Okay, so so as I was saying, I came up with a particle physics for kids series of virtual camps. So I decided that if school was in session and it wasn't that interesting just doing hands-on experiments with me, I do a series of sessions with guest hosts from CERN, from GINA in Russia, the Perimeter Institute in Canada, Fermilab in the States, and again, invite kids from around the world to come along, learn some particle physics, tie in some simple hands-on experiments they could do at home at the same time. And similar thing, ended up having students and now more teachers than ever from, I think I said up to 30 countries, over 30 countries. Usually there's students from like 5 or 10 countries at any given session. And I'd originally intended on doing this just for a couple of months in 2021, but with encouragement from the International Particle Physics Outreach Group, who I met through doing these virtual camps, then I started it again this year. And actually just this week, I decided to shift from a once or twice per week style of camps that was only going to last till the end of April. And I've decided to do it so it'll be 1 or 2 sessions per month, but to keep doing it just like long term, all through the year. So if any of you are interested in particle physics or have students who are interested, please join in. The next visit is tomorrow it's at 6 Paris time, which I guess is 7 in Turkey. I don't know for sure what time it is in Azerbaijan. It's an hour later than Turkey, or is it an hour and a half later, or the same time?
No, we have 1 hour different from Turkey. Now here, 11, 10 minutes to 11.
Okay. Which is a good reminder. I should go a bit quicker because I think we said we'd take about an hour. That's right.
So the name of the page is Particle Physics for Kids?
Exactly, yes. And a little bit later on, well, actually here, there's even the link to register for tomorrow if you're interested. But there's a clickable link at the end, and I'll put it in the chat as well at the end of the presentation if you want more information on it as well. Because like there's the page that has the calendar. There's actually nothing on the calendar for the rest of April, because I need to confirm the date for 2 weeks for now. I think it's going to be Wojtek Pleskot, who's in the Czech Republic. But the next camps aren't lined up yet, but there's going to be one more in April and then 2 in May and probably 2 in June, then a break for July and August. But I'm definitely eager to share the link for that, and definitely eager for more people to join in. Continuing on, and I'll kind of skim through the more recent projects because they're ones that you can actively join in. And so I have like websites you can look up more information on them. And but 2 new ways, kind of inspired by the virtual camps, for both teachers and students to share experiments together. One I call experiment shares, and they're Zoom sessions once a month for any teachers who want to join in to share simple experiments with each other. And the idea is that whoever wants to sign up can sign up and spend about 5 minutes sharing a quick experiment. Whoever just wants to come along and see new experiments, they're more than welcome to just watch. And so usually about 1 out of 4, 1 out of 5 teachers will present something. And so it makes for me, I find a really interesting hour or so where you can see 5 or 10 new experiments from around the world. And that happens every month. The next one is the day before Earth Day. I don't know if you guys celebrate Earth Day in your part of the world, but April 22nd in a lot of countries, they celebrate Earth Day by doing a lot of either Earth related or like ecology and climate related experiments and activities in schools. And so the idea of celebrating Earth Day Eve is the evening before. Teachers can share short experiments that anyone who's looking for something new to try out right the next day, they can try out the next day in their class. So that's the next one coming up. And here's, I guess this was the February schedule, just to show the different types of things and types of materials. To quickly go like clockwise around the circle, there's Astronauts in Greece showing a counterintuitive can that rolls up a hill rather than down, demonstrating some things about center of mass. David Featonby in England, demonstrating a couple things about bubbles. Takis in Athens, who's demonstrating standing waves on a string. Me doing the static electricity with the straw that I showed you guys. And this one in February, I did silent. The reason for that is in May, the experiment share is going to be silent. And the reason for that is with these meetings with teachers from around Europe and around the world, then only a minority of us are mother tongue English or are very comfortable in English. And there's a number of teachers I've met who are a bit shy to share experiments when it's not in a language they're comfortable with. So I said, well, one way we can try and get around that is if no one's allowed to talk at all, and we all need to share experiments in silence. So I'm really looking for that one and seeing how it works out. There were a couple other cool ones there, like this one was from Marco in Germany, showing a version of the Michelson-Morley experiment, which was done to essentially prove that light travels the same speed in all directions, but doing an analogy with sound and using a smartphone sensor. Freezing bubbles one of a Brazilian student who was in Canada and wanted to do things with freezing. Carolyn in the UK doing a density bottle. Paul showing magic as usual. He's a great teacher. And Sophia and her mom, Gordana in Serbia, showing one where you can derive Pythagoras' theorem using shoelaces on the floor of a lab. So like there's always a cool variety of stuff being shown. I think we're short on time. Do you guys want to see the magic pendulum, which is a fairly quick one, or should I skip it to get to the end of my presentation?
Yeah, you can show us.
Okay, so I will show it. Okay, so I'll unshare the presentation. And here is what I'm calling the magic pendulum. And I'm going to move my camera a little bit, well, my computer with my camera a little bit further away again. And yeah, I'm going to take out my head. And you should be able to see, oh, yes, this pendulum with 3 different lengths of string. And I wanna pick someone. Let's pick Aynur in Azerbaijan. Can you be my volunteer for this experiment?
Okay.
Okay, so I want you to pick one of the strings, the short, medium, or long one.
I can pick one only.
Yes, well, for now, just pick one. You can pick a different one afterwards, but choose short, medium, or long.
I choose
Medium, medium.
I choose short. Beril took.
Okay, short.
Short? Okay, so short. And I want you to try, just with the power of your mind, to get the short one moving back and forth over the distance we're apart. And we see the short ones moving back and forth. The other ones are barely moving.
Yeah.
So then my question is, how did that work? Well, and I guess you'll see it better when, like, my sweater's behind it. Now let's try with the medium one. So whoever was eager for the medium one, now we'll see if the medium one can get going. And we see now the medium one is swinging wildly where the others are barely moving. So then the question is, how am I doing this? Maybe if there's a physics teacher in the room, they might have a good explanation.
Yeah, it is very actual. I think you took your balance only which one you choose. Yeah.
So I choose one, and then what I do, and I'll do it from the side. If I swing everything, you can see they swing at different speeds.
Can it be related with the length of the ropes?
Exactly. So the longer one is swinging back slower than the shorter one. So if I look at when it's swinging on its own, like here I'm doing the middle one, I go forwards, back, forwards, back, forwards, back, and doing it in time with it, I barely need to move the top. So if you're looking at the bottom and I'm only doing it slightly, you might not even notice that I moved the top. And all we see is the result of the one that you've chosen to move. So if we see the small one again, then, or the middle one, let's say the middle one. So barely noticeable, I'm moving it forwards, back, forwards, back, forwards, back. And then we get it swinging big with a barely perceptible motion of this one.
Yes.
So that's a fun one to demonstrate a physics concept, but you can try and convince your students it's a magic trick and you can perform telekinesis. After seeing that one from Astrinos at my experiment share in November, it quickly became one of my new favorites again. I'd actually originally seen a version of it in Spain back in 2018, but I kind of forgot to share it with students or to share it with more people. But since November, I've shared it with a number of people. I think, yeah, I'll go back to my slides because I'll explain some of the places where I've shared it. I've lost my slides again.
Won't you share the answer with us? We are wondering.
So sorry, can you repeat that, please?
Won't you share with us the answer?
Oh, the answer to how it works?
Uh-huh.
Oh, I guess I went a bit too quick on that. Yeah. So I'll stop sharing again. Hopefully I'll find my screen one more time. So
We are all wondering, I think.
okay, so
Why is that?
explain it quickly because I'm trying to finish fairly quickly here, but to explain it one more time. So it's good if you can kind of see the whole thing. So if they're all swinging, then we see the shorter one swings back and forth quicker, the longer one slowest. And if I move the top at the speed it's already swinging, so if we look at the long one, if I go forwards, backwards, forwards, backwards, forwards, backwards, then I'm getting it to swing because I'm moving the top rod at the same frequency it's spinning.
Okay.
Similarly, if I go to the short one, that's going a lot quicker. So forward, back, forward, back, forward, back, forward, back. And we see that swinging bigger than the others. And if I make it a lot more subtle and I'm barely moving it, then it should really only mainly move the one I'm trying to move. So we'll try the short one again. And here, forward and back, but only a tiny bit, so you can barely see me moving the top one. Because our attention is drawn to movement, and it's swinging much bigger than the top part is swinging. But I'm swinging the top part just at the same frequency this is going back and forth.
Okay, thank you. Thank you so much.
Oh, you're welcome. And thank you for asking, because I went too quick the first time. And if you don't know how to repeat it for students, there's no chance you're going to redo it.
Okay, thank you.
And I think I'll probably skip the last experiment, but I'll still get back to my slides so we can get to the links I'm going to share to you guys, because hopefully some of you guys will be interested in joining some of these. And they, like almost everything I do, is open to absolutely everyone who wants to join in the fun. Okay, so now I'm just searching for my slides once more. You should be able to see it now. Here's some pictures of some of the places that I've shared this magic pendulum or resonant pendulum. So you can see here is in a school in Serbia in December. Here was at a scientists conference. So it was actually the National Scientists Conference, and it doesn't come out so well in the photo, but these are actually bananas hanging from the pendulum. And that was a bit of a funny story. I was visiting a friend in Serbia, an excellent English teacher, and going to his school, sharing experiments, trying to meet a couple of other teachers while I was there. And the Saturday morning before flying back to Paris on Sunday, I sent out an invitation to all of the scientists ambassadors in Serbia and all the people involved in science on stage. And I said, I'm trying to have an in-person experiment share at this school. So a couple of teachers showed up there. And then one of them, Tanya, who's in the background here, said, there's a scientists conference this weekend. You didn't know about it? And I said, no, like in France, we don't get the Serbian news for that. And so she brought me there, introduced me to Mariana, who's the director of scientists for Serbia. And she invited me on stage to give the final address for the conference. But the talk just before mine was about bananas. Well, bananas were a recurring theme. So I said, okay, I'll adapt a couple of experiments to include bananas. So that's why I'm doing it even with bananas here. And then the bottom one is in Ghana in February, or the very beginning of March. I was there the last week of February, first week of March. And I started showing it at some of the schools I visited there as an example of an experiment where I get a stick from the courtyard of the school and rocks from just outside of the classroom to show them that even with things like sticks and rocks that you can find just outside of the classroom, you can still do interesting and surprising experiments. As I mentioned before, the next two experiment shares, the Earth Day Eve, April 11th, and the silent one is probably going to be May 8th. I've been asking people signing up for other ones what day works best. That's the leader for now. But if other people prefer another date, then it'll be another date, and I'll announce that at the Earth Day Eve one. Just to quickly mention, Yes International is like a student version of the experiment shares. So my student science club in Paris, I call Yes for Young Enthusiastic Scientists. It's an acronym. And you saw a picture of Anna and Alice, who were sharing a beer bottle thermometer when they were with me in Ghana. We founded Yes International to keep in touch with the schools we had worked with in Africa. And just a couple months ago, we started expanding. So now we're expanding to anyone else who wants to join. And you'll see on the schedule, March 14th was the very first open Yes International. And so there, anyone who wants to sign up, any student at any school anywhere can sign up for a 5, 10, or 15-minute slot to share an experiment. If any of you guys have eager students who want to share, the link I think is on the next slide. I'll go to the next slide to see. Oh, no, I'm going to skip this experiment because it's getting late, unless you ask for me to do it afterwards. But here's a bunch of links. So if you're interested in any of the projects that I talked about, the particle physics for kids, which came up, and I'll copy all these links into the chat in hopes that some of you guys will be interested in them.
Share on chat. Maybe our teacher will join.
Perfect. Yeah, I'm just getting. I'll probably stop sharing my screen so that I can see the chat, because I might have. Can you guys still see my screen right now if I leave it up?
Yes, we can see.
Okay, so I'll leave my screen up, and I've added all those links into the chat.
Thank you.
And so that's been a brief introduction to who I am as a science teacher in Paris, someone very interested in learning new experiments around the world and sharing them forward. So a little bit of what I do with Science on Stage France and as a scientific ambassador for France. Hopefully it's been interesting for you guys to hear about some of these projects. Hopefully a lot of you will want to join in some of them. If not, no worries. Like, that wasn't the whole point of the talk. It was to introduce how I teach and some ideas about how I teach. So hopefully you guys have some questions either about the experiments I showed or some of the stuff I do. But please let me know if you have questions.
Yeah, teachers, if you have any question, please ask. We have time. And I thank you very much. The presentation was great. Experiments very, very useful and very informative.
Oh, thank you.
Yes.
And thank you for the opportunity.
In fact, in our curriculum, we have some such subjects in English, for example, science and also natural forces like this. We can use these experiments in our lessons too, for example, for warm-up. I really like it, and I really wonder the other experiments about your organization or from your friends. So I really like this presentation too much, and I'm very happy to meet you. It's a big honor for me. I hope we can come together previous experiments again.
Oh, with great pleasure. Yeah, I'm glad you liked it. And if you're interested in some of the other experiments, then like with the experiment share, I have like just a Google Doc that goes over the experiments that were shared each of the months. And I've put a recording of the Zoom session on YouTube so you can see all the experiments. I didn't do the August pilot, but like from November till now, each one of those is online if you're interested in seeing what's been shared before, which could be a good way to check things out if you're thinking of coming to one of the next ones, to know if you're interested in it.
Yes, thank you.
Thank you. Do you have any ideas coming to Azerbaijan?
Like to travel to Azerbaijan?
Yeah.
I'd love to. I don't have any plans yet, but I'd be happy to come if we set something up, like if we organize a conference or workshops or anything like that. Yeah, it seems like an exciting place to go to.
Yeah, I will share with you. Maybe here take place some organization about STEM or science teachers. We will have some Technofest festival. There is joining some from Turkish and Azerbaijan teachers there, BCS students. They are making plane or rocket instruction. It will be on May, and I forget which day, but I will send you the link and you can search about this conference.
That sounds good. Thank you. May is a pretty busy month for me already, so I'm not promising I can come in May, but I'll look at it, and like if I'm free, I'll definitely try. But depending what date it is, May might not be good. But let me know. I'll look into it.
Okay. Okay. Yeah, teachers, do you have any question, or maybe you have any ideas sharing with Michael? Don't be shy. Our teachers are listening, almost listening, learning. STEM is very interesting for all of us because we are English teacher, but we are try to integrate as a subject in our lesson.
I want to say thank you. All the experiments are very interesting for me. I'm not a science teacher, I'm an English teacher. I want to answer your question during the experiment, but I think my answer will be very foolish for you because I'm not a science teacher, but I will try these experiments with my students. I'm new in STEM project, and they are really interesting for me and for my students.
Oh, that's great to hear. Thank you. And try not to be worried about getting things wrong. Like intentionally, both with teachers and with students, I try and show something where it's easy to get the wrong answer.
Yeah, well, actually, the second experiment, I think that the cover is moving because of the airstream. If we cover the glass, it will stop moving. It's my idea, but I'm wrong.
But it's good to test things out, and that's one of the best ways to teach the scientific process to students, to go through different ideas and test out if we try this, like if we try covering it, then we'll see if it still goes to the side. And if it does, then we know that that's not what it was and we need to keep looking. And like that's how science works. We always look for different ideas and test them out. And more often than not, a hypothesis won't work out. But by trying something and knowing it doesn't work out, we can often learn more than if what we try works the first time.
Yes, but we try to create new ideas and new solutions.
Exactly, yeah.
Thank you.
Oh, thank you.
Do you have any interesting experiment or idea about natural forces?
Natural forces, like forces that occur in nature, or like
earthquakes, tornadoes, landslides, like this takes.
Oh, okay. There's two or three I can think of. None that I have like everything to demonstrate here, but you guys have probably seen like a vortex in a bottle where you have like a bottle of water, and then trying to think if I had a bucket handy, I could demonstrate it. But one of the ones is just if you take a full bottle of water and you dump it out, then you'll have a turbulent flow where water will only come out when there's a bubble and a bubble and a bubble. Whereas if you spin it around, so you get like a tornado type action where it's spiraling out, it'll actually empty significantly quicker. And so just by taking 2 bottles of water and having a race, like you could turn it into a small game where 2 students have identical bottles and they need to empty one quicker than the other. And you can see the one who makes a vortex or makes a tornado shape will empty it quicker. And that can demonstrate that the spiraling around can have a quicker exchange of fluid both downwards and upwards. And that's one of the reasons why a tornado will spontaneously form when you have a difference in pressure in the atmosphere, because that'll be the most efficient path for two fluids of different density to change. So like in the case of the bottle, it's actually going to be one is air, which is a gas, and the other is water, which is a liquid. But you can still show that the spiraling makes it so it can flow quicker. And in the case of a tornado or a bigger scale of hurricane, then that ends up happening when you have a weather system inversion, like where you have a cold air mass on top of a hot air mass. And of course, what normally happens is hot air rises, cold air falls. But if you have a big enough difference, then you'll have an isocline, which is like a layer where it's hot and cold on either side. And to break through the isocline, you'll have air that spirals around. So like that takes a bit of explanation why the bottle situation is similar to a tornado. So it's like not a perfect modeling of it. For an earthquake one, it'd be good if I could find the link handy. My friend Astrinos in Greece, who's a Science on Stage ambassador, just last weekend, like a week and a day ago, was presenting an earthquake detector at the Science on Stage Festival. And that was one where he used, I forget if it was a microbit or if it was a Raspberry Pi. Like it was a cheap microcontroller to program a couple of different things so that it would be an early warning earthquake detector. So if you're interested, I'll ask him for the details on it. Like I'm pretty sure he has a write-up online.
Yes, I want, because we have in natural forces unit, and we can use these things for warm up or get relax our students. So it appeals too much.
So I'll ask Astrinos for the information on it. If I don't send you something tomorrow, send me an email to remind me to follow up with him.
Okay. Thank you so much.
Oh, you're welcome. Oh, and there's another really fun one I'll describe for earthquake engineering. And that could come up as a useful topic in somewhere like Turkey because it's quite seismically active. And this is an experiment that was developed at the Exploratorium Teacher Institute, which is in San Francisco, which is also very seismically active on the San Andreas Fault. And what they do is they take a skateboard, like skateboarding is pretty common there. You could do it with just a board on rollers, but like everyone has skateboards. And you attach it with bungee cords, like elastic bands. And I've done it with inner tube from bike tires because that's cheaper. Like if you're changing a bike tire or you go to a bike shop, you can get that for free. But you have it held stretched, so the skateboard is held very tight in the middle. And then when you pull it back, it'll vibrate violently back and forth. And so they use that as the earthquake table. And students build different structures out of spaghetti or spaghetti and lasagna, and like different simple materials. And the idea is they need to try and build a structure that will be able to survive earthquakes of different strengths, which would be from pulling back the skateboard to different levels. And so they go through different iterations where from the first design, you'll see how it falls. And then you try and rebuild and redesign so it hopefully doesn't fall the same way.
Yes, that's so enjoyable.
I'm going to make notes of different links I should send. If I send them to you, can you send them on to the other teachers if they're interested?
Yes, the others, do you want? Yes, I think they want to.
Yes, they want, but they don't.
Yes, we want.
But are too shy to ask.
Others, and we discuss, I think.
Okay, but because like for Astrinos, I'll need to hear back from him. The earthquake shake table, I can probably find that link, but like I'll do it tomorrow because it might take a couple minutes to find. Was there anything else I said I'd send to you? And does anyone else have anything they'd like to ask?
They can ask, and they can write a chat box too.
Oh yeah, of course. Feel free to write in the chat. Yeah.
Yes, you can use chat to write your question, or maybe you want to get an ideas. If you not, I think it is enough. And yeah, because it is very late. Yeah, forget and we get your much time. Thank you for your sharing, and I think it will be interesting for our teacher, and they will be use it in class too. Thank you so much.
Oh, you're welcome. And if anyone wants to take any pictures of using it in their classroom, it always makes my day if I see someone using something that I've shared with them as well.
Yeah.
Okay.
Yes, can. And I
Sure.
hope we can meet again any day, other days.
Sure. Yeah, with pleasure.
Okay. And our teachers will be very active next time. Okay. Thank you. Beril, do you have any?
Yes, I really appreciate to be in here, and I really like the presentation, and I never and ever get bored. It's so enjoyable. And maybe for the next time you can show us a bit social experiments about STEM. Maybe it's just an idea.
Oh, like sociology, or like what kind of experiments?
We can use in our lessons, for example, about life, not only for science, maybe maths or casual, about casual life, maybe technology. Yes, I don't know.
Okay, I've got some good technology ones. Yeah, let me know before next time. Like remind me of that, and I'll work some in.
Okay, we really wonder to come together again.
Yeah, with pleasure. I'd love to.
Thank you. So very, very thank you.
Oh, you're welcome. And thank you to all the teachers for joining. It's always great to have a good group and to connect with people in other countries.
Okay, maybe we can do some project twinning. We are all a twinning teacher. We like to work there. And Michael has a twinning account, but he don't use mostly it. And thank you so much. Good luck. And I hope we will take other meeting soon with our teachers.
That sounds great. Thank you again, and have a great night, everyone.
Thank you. Is it in Buenos Aires in French? Do you speak in French too?
Oh, I speak French like at home with my girlfriend. I speak French with my students. I usually speak with them in English because it's a bilingual school. But most of them are French, and I'm supposed to speak with them in English. But it depends who I'm speaking with and what we talk about, which language we stick with.
Is it a good night? It is Buenos Aires or Buenos?
Oh no, it's bonne nuit.
Bonne nuit. It is in French language. Buenos Aires or Italy.
Have a
I
good
tried
night.
to learn French, but it is very difficult for me. It is very good language.
Yeah, no, it's a difficult language.
Yeah. Thank you. Good luck.
Thank
See
you.
you soon.
See you.
Thank you.
Thank you so
Goodbye.
much.
Bye.
Bye.